Macy to the fall semester correction video. Let's take a look at your exam and see how you did. You made a 97 on it, and I think you've already received an email on that. I took all of your mistakes and I multiplied them by 0.6 and subtracted from 100, and you got a 97. So you did really, really, really well. But let's still look at your mistakes here. Page number 1, numbers 1 through 7, there were no mistakes, so good job there. Moving on to the next page now. Okay, it says here, number 8, now listen carefully, Macy, and you'll understand this. Write statements A and B in if-then form. Now it says 2 points are collinear if they lie on the same line. So I was not trying to trick you. I was trying to make this pretty simple. If I said to you, Macy, sorry, excuse me, a little congested there. If you score, okay, if I said to you, I will buy you ice cream if you score 3 goals. Well, obviously the if part, the condition, the hypothesis, the deal is if you do this. I'm not saying if I buy you ice cream then you'll score 3 goals. That's not what I'm saying. Although that might be a good motivator. I don't know how much you like ice cream, but I'm saying now if you score 3 goals then I will do this. Hopefully you see the difference there, okay? So I'm saying if these points lie on the same line, then they're collinear. So you did this backwards. You said if 2 points are collinear, then they lie on the same line. Now, yes, I'm not going to argue with you. This is a true statement that you wrote. That's true. It's true. But you did not write it in the proper form. I wanted you to take it and write it and take this statement here as it's given and write it in if-then form. Okay, so if they lie, if 2 points lie on the same line, then they are collinear. Okay, now of course if you made a mistake here, I'm not going to take off points down here when you write their converse. So you took this here and you wrote its converse correctly, and that's fine. Okay, but no, this one here you should have gotten right. No way I'm intended. You did really well, but one of the statements in number 11, one of these statements here or here is false. So you identified the one that's false, and it's this one right here. Good job. Then I said given a counterexample. So let's see if you did, okay? If a number, can't get my pen to work, here we go. If a number is divisible by 3, then it's also divisible by 9. So you gave 18 as your counterexample. Well, let's see. If a number is divisible by 3, 18, then it's also divisible by 9. And it is. So your counterexample is kind of funny. Your counterexample did not prove this wrong. It actually proved, well, it didn't prove it, but it actually supported your counterexample. It actually did the opposite. It supported this statement. You gave me an example that is divisible by 3 and is divisible by 9. I need you to prove it wrong. I need a number that's divisible by 3 but not divisible by 9. How about 21? 21 would work fine, right? 21. I'm saying if a number is divisible by 3, that's 21, then it's also divisible by 9. Nope, not 21. So 21 would be a counterexample, and there would be other ones also, but you need a number that's divisible by 3 but is not divisible by 9. I hope that makes sense, okay? So you made that mistake there. Let's see what else we got in this. I think that's it for that page. Yeah. All right. Moving on. Now, did a really good job on this page. Wait, one little mistake here. Number 26 is the one you emailed me about. Now, here's your work. Now, please look at what you did. Okay. You took 3x plus 2 which is this angle right here. Okay, this angle here, got it? And you added to it 3x minus 6, which is angle B, this angle here. Now think about that. You add them together and set them equal to what? 180. Got it, Macy? See it? Now, from there, your work was impeccable. Even though this equation is wrong, and I'll show you why it's wrong in a second, you solved it correctly. You then found the measure of angle ACB, which is this angle here. You did great. Okay? You found, anyways, I'll get to that in a second, but the equation here is wrong, and here's why. Think about it, Macy. You said this angle here and this angle here add up to 180. Now that's impossible because remember the three angles inside of a what? Triangle have to equal what? 180. So it's impossible for these two angles to add up to 180. If so, that means this angle here is 0, and that's impossible to have an angle instead of a triangle at 0 degrees. So these two angles here, A and B, cannot add up to 180. Well, Mr. Arrett, what in the world am I supposed to do? Well, I'm glad that you asked. Here's what you're supposed to do. And by the way, so don't ever quit showing your work. You only lost one mistake, 0.6 of 1 point, because of all this great work that you showed. After you made this one mistake, your work from there was perfect. It was great. So always, that saved you so many students at Berean that I teach, other homeschool students. They just are lazy. They just don't show their work. And that's a good job that you did that. So what do? Well, we learned a theorem earlier this year. Here's a triangle. If you have an exterior angle, it equals the sum. That means you add these two remote interior angles. So if I take this angle here, angle A, plus angle B, it will equal this outside angle, which is what? Okay, so angle A is 3x plus 2, angle B is 3x minus 6. I'm going to solve this very quickly for you. 3x and 3x is 6x. 2 and negative 6 is negative 4. So there I have completely simplified my left side. Bring your 2x over, make it negative. Bring your 4 over, make it positive. And you're left with 4x equals 12. So x equals 3. We're trying to find the measure of this angle right here. So where x is right here, I'll put a 3. 2 times 3 is 6, plus 8 is 14. So this angle right here is 14 degrees. No, it doesn't look like it, but that's okay. So this angle right here is 14 degrees. We know this whole line here is 180, and you know what to do because you did it here. You took this and subtracted it from 180. That's how you got this right here. So you know this already, but take 180 minus 14, and you'll get 166. Okay? And that's the answer. Alright, moving on. Hope that helps a little bit. Alright, now on this page here, you missed this problem. Okay, real quick, here's why they're not congruent. Let me show you. Triangle ACD. Let's trace it for you here. So I'm telling you, Macy, it helps a lot to pull these triangles away. Okay, it really does. So here's triangle ACD right here. And let's see if I can pull this down. It's not going to work. I will do it right here. And then the other triangle is ECB. So E. Wow, that's a really good straight line, isn't it? E, C, B. Alright? So there's the other triangle right there. Now let's label these sides. See this 4 right here? That goes right here. 5 plus 5 is 10, so this whole side is 10. This side here we don't know, we'll call it side BE. Okay, this length right here would be 5. This length here would be this length here. 6 plus 4 is 10, and of course this length right here is this length here, we'll call that AD. Now they share a common angle, so I can say this angle is congruent to this angle. But right away, Macy, you know these two triangles they're not congruent because you don't have side angle side. Yes, you have a 10 congruent to a 10. You have an angle congruent to an angle, a side angle, but then if this 4 was a 5, then yes, you could say this side is congruent to this side, and you would have side angle side, but it's not. This side here has a length of 5. This side here has a length of 4. No, they are not congruent. Okay? Hope that makes sense, and it really helps to pull those triangles apart sometimes. Okay, now this was a tough one, but tough problems are good for you. You said yourself, well, first of all, I said that these three lines here, now watch carefully, BG, DG, and FG are all what? Perpendicular bisectors, which makes the point that they intersect right here the what? The circumcenter. So look what you wrote. This is perfect. Great job. You're right on. The circumcenter is what? This point right here is a circumcenter, right? It's equidistant from where? From the vertices. So if I ask you to draw three lengths that are congruent, that means this point is equidistant from the vertex. So you should have drawn that line. You should have drawn, here's a vertex here. So the line from here to here is a segment. Here's a vertex. Draw the line from there to there. Here's a vertex. Draw the line from here to here. And those three segments are congruent. Now, I would have given you credit if you would have put AG, CG, and EG. Okay, but you put these segments. You said this segment is congruent to this segment, is congruent to that segment. That can be true, but it's not necessarily true. Okay, these three segments are called what? These three segments here, 1, 2, 3. Those three segments are called perpendicular bisectors, and where they intersect is called the what? Circumcenter. And what do we know about the circumcenter? They're equidistant from the vertices. So what I wanted you to draw was, I said draw the three lengths that are congruent. It's these lengths here, or you could have written them there. I hope that makes sense. And then lastly, oh yeah, one little mistake here and we're done. This is it. Okay. So, and by the way, I did not take any points off on this because I felt like you might have been confused where angle 1 was. So that's why it says -0, but I still want to show you what you did wrong. Now, Macy, please listen and follow my reasoning, okay? ABCD is a what? A rhombus. Okay, now what do we know about rhombuses? They are automatically what? Well, they're parallelograms. And you knew that. So you knew if this angle here is 80, because a rhombus is a parallelogram, then you knew that consecutive what? Angles have to be what? Supplementary. Good job. So you knew this whole angle here from this angle here, from here to here, that whole angle there had to be 100, and that's good. But I was asking for angle 1, which is here to here. Now, there's a property of rhombi that you have to remember. Here it is. Are you ready? When you have a rhombus, the diagonals always bisect. I don't know why I put perpendicular, that's the wrong symbol. The diagonals will always bisect the vertex angles. So that means this is a diagonal. It's going to cut this angle in half. So if the whole angle here is 100, then obviously this angle here has to be what? 50. Okay? I hope this has been a help to you. If you have any questions, Macy, never hesitate to email me. I hope you have a great rest of the Christmas break, and we'll talk to you later.